Mathematics is the language in which God has written the universe, says Galileo Galilei. Pure mathematics is, in its way, the poetry of logical ideas, says Albert Einstein. All such great personalities in their time taught us that mathematics is a precious tool to understand the precise nature or say precise behavior of this universe. Today also, we're going to define such one of the most fundamental mathematical object which will help us calculate distances in any kind of geometry, say the geometry of our universe itself. Don't worry, I will not complicate things much. But do you remember in your school days you have studied the simple Pythagoras theorem, which says in a right angle triangle, the sum of squares of base and the perpendicular is equal to the square of hypotenuse. Let's say your hypotenuse is denoted by s, base by x, and the perpendicular by y. Then you will have this equation. Now, given us the values of base and the perpendicular x and y, we can find the length of hypotenuse x by taking the square root both sides. Now, notice what we have just done. We have just found a way to define distances in a two-dimensional space where the base and the perpendicular are defined in two dimensions normal to each other. Just by adjusting or changing the values of base and perpendicular, that is x and y, we can find any distance as between any 2 points in the two-dimensional space. Now I can extend it to 3 dimensions where now the distance will be given by the square root of this equation. Now notice that both of these equations have positive signs in front of all these terms, which describe simple 2D and 3D geometries which we call Euclidean geometries. But what if I have the case in which the distance is given by this equation? It's an example of non-Euclidean geometry. Now, what I want to say that we need a more fundamental mathematical object which help us to study the more complex geometries. And this thing can be achieved just by taking really very small distances, infinitesimally small distances denoted by dx, dy, dz. Our previous equation now read as this equation. Now you can calculate distance as just by integrating the square root of this distance in the proper limits. It is similar to as if you want to construct a big complex house just by integrating the smallest possible objects bit by bit, brick by brick. Now this equation, this fundamental equation defines our required mathematical object. We call it metric. It is a distance function or say a rule book which tells us how to measure distances in between any 2 points in any kind of geometry. Thank you.